Hello friends, here is this afternoon's anticipatory set. We have tiles, different colors with the frequency tables shown on the right. Then I'm asking you to find the following probabilities. This is all an experiment that they did. So pause the video, see if you get these 5 answers for the probability. Okay, so hopefully you figured out how many possibilities was to get red out of the total amount. So you would have to add them all up. So that's 8 out of the 39. For yellow, it was 12 out of 39. Green, it was 9 out of 39. And blue was 10 out of 39. And there was no probability at all, so that was a probability of 0. Okay, so we're moving on today to ELR 13.4. Yesterday, I gave you a review of the mid-chapter review on Pearson. Hopefully you were able to log in online and get that done. So today's objective is to identify independent versus dependent events and how to find compound probabilities depending on what they ask in the question when two things are happening together at the same time. There is a homework for this week. It's due B block. From the textbook, that whatever we learned today, 6 through 9, 13 through 21. You could submit that through Google Classroom on B block day. There will also, of course, be the exit ticket for attendance for closure. We will be having a open no quiz next week on Monday, that 1 to 8 day. It's going to be a Google form quiz. Some are going to be multiple choice. Some are going to be showing me work there on Monday's quiz. Again, if you have any questions, please email me. Okay, so in your notebooks, definitely write your ELR 13.4 on the top. I want you to think about the following 2 questions before you go to the next part of the video. What is a compound event to you in probability? What would be an independent versus a dependent event? Okay, so here are some definitions here. So a compound event is an event that is made up of 2 or more events happening. An event is independent if that event does not affect how the other event occurs. And a dependent event is an event that does affect the other event. So for example, an independent event could be something like this. If I was to roll a die, what's the probability of getting a 6? And then if I was to spin a spinner that had a certain amount of colors, what would be the probability of, if it landing on red? So a die and a spinner have nothing to do with each other, so that event will not affect the other event. A dependent event would be where, what would be the probability of rolling a 6? And then after that, rolling an even number. Those both deal with the same thing, dice, so that event would affect the other event. All right, so I'm going to put a couple of questions here identifying if it's independent or dependent event. So if we were in class, I would have had you stand if it was independent and stay seated if it was dependent. So here's the first example here. If I was to choose a number tile from 12 tiles and then spin a spinner, is that independent or dependent? That's definitely independent. The tiles have nothing to do with the spinner. Okay, here's the second one. Pick one card from a set of 15 sequentially numbered cards. Then, without replacing the card, pick another card. So this is definitely dependent because you are not replacing the card. That first event will affect the second one with the cards. Okay, here's the third one. You roll a standard cube, and then you flip a coin. Those 2 events are independent. Cube has nothing to do with a coin. Okay, now we're going to get 3 different formulas in this section here. So the first formula is dealing with if they give you independent events, and they ask you to find the probability of these 2 independent events. So we're saying that A is one event, B is the other event. And if I want to find the probability of these 2, I would get them each separate and then multiply them together to get the probability of both together. So let's take a look at an example of this. Okay, here we have a desk drawer. Contains 5 red pens, 6 blue pens, 3 black pens, 24 silver paper clips, and 16 white paper clips. If you select a pen and a paper clip from the drawer without looking, what is the probability that you select a blue pen and a white paper clip? So you're selecting something that has one thing that has nothing to do with the other, that won't affect it because we're not looking, we're just pulling out 2 things. So this is the probability of finding 2 independent events. And here was the formula that you got from before on the previous slide. So what's going to be event A and event B? Well, event A is selecting a blue pen. Event B would be selecting a white paper clip. So let's go ahead and follow the formula, which says I'm going to take probability of event A and multiply it by the probability of event B. All right, so what's the probability of picking a blue pen? Well, there's a total of 6 blue pens. How many things all together in this drawer? If I add up 5 and 6 and 3, 24 and 16, I get a total of 54 items. What's the probability of choosing a white paper clip? There are 16 of those in the drawer out of a total of 54 items altogether. I'm going to go ahead and multiply this out. And when I do this in the calculator, I have parentheses around those fractions when I multiply. And then I'm going to hit math frac to reduce the fraction. I get it to be 8 over 243 as the probability. If I get the decimal for this, it would be about 0.03, which is about 3% probability of selecting a blue pen and a white paper clip. Okay, second example. You roll a cube and spin a spinner that's right here on the below. What is the probability that you roll a number less than 3 and the spinner lands on a vowel? Okay, so these are 2 independent events. So I'm going to be figuring out the probability. So the probability of a number less than 3 on a cube is the numbers 1 and 2. So we have 2 possibilities out of the total of 6. The probability of a vowel on the spinner is just that, the letter U. So that's 1 out of 4. And because they're independent events, we're going to multiply them. We get 2 over 24, which reduces to 1/12 as the probability. Okay, next thing that we're going to be getting into, another formula, is what if events are mutually exclusive, meaning events that cannot happen at the same time? Can you think of an event like that where it would be mutually exclusive? All right, so when you see a question like this one, it will have the word or in the sentence there. The independent events, when we had the 2 questions before, that one had the word and in the sentence, if you notice, for the question. So here is an example. Here is the formula, for mutually exclusive events. So you would find the probability of A, but this time instead of multiplying them together, you're going to be adding them together because they're asking for the probability of A or B there. So here's one example below. In the spring season, 15% of the athletes play baseball and 23% are on the track team. What is the probability of an athlete either playing baseball or, so that's the magic word, being on the track team? All right, so we're going to find the probability of baseball, and we're going to add that on to the probability of being on the track team. These are both percents, so we're just going to be adding them up. So 15% for baseball, 23% for track. When I add them together, it's a 38% probability of either baseball or being on track. Okay, third thing for today's ELR. Sometimes events can be overlapping, meaning they have outcomes in common. Can you think of an event that's an overlapping event? All right, one thing that could be an overlapping event is when you roll a die, depending on what kind of questions they ask you for the probability of. So here is two examples here. First one here is, what's the probability of rolling either an even number or a multiple of 3 when rolling a standard number cube? All right, so the formula, which is down below, which I suggest writing in your notes, says that if A and B are overlapping events, we're still going to be doing what we did for the mutually exclusive events. We would find the probability of both events and then subtract what they have in common at the very end. Okay, so let's go back to that first example again. Probability of rolling an even number or a multiple of 3 when you're rolling a standard cube. All right, so here are our numbers on a standard cube, 1 through 6. These are definitely overlapping events because you could have a multiple of 3 that's even. So we're going to find the probability of the first event, which is getting an even number on a die. Then our second event, B, is probability of rolling a multiple of 3. And then we're going to subtract away the common thing that they're sharing, because we don't want to repeat it, is having an even number and a multiple of 3. Okay, so how many even numbers do we have on this cube here? All right, so we got 2, 4, and 6. So that's 3 possibilities out of a total of 6. How many are multiples of 3? So what can I divide 3 by perfectly? So I have the number 3, and also 6 is a multiple of 3. So I have 2 possibilities of getting that out of the 6. And then minus, well, what do they have that's being shared? So what is even and a multiple of 3? Well, this is the only possibility, is the number 6, that's even, and that's a multiple of 3. So I want to take that one away from what I did before. So that's 1 out of the 6 possibilities. Then I go ahead and add and subtract. So 3 plus 2 minus the 1, I get 4, 6, or 2/3 as my probability. All right, you guys try the second one. Pause the video and see if you could get what's the probability of rolling an odd number or a number less than 4. All right, so when I did that, a probability of odd, I had 3 possibilities out of the 6. Adding on to it, numbers less than 4 is 1, 2, and 3. So that's also 3 possibilities out of the 6. And then what do they share in common? That's the one that I have with the arrows in green. 1 and 3 are both odd, and they are less than 4. So when I add and subtract and I reduce, I get also the answer to be 2/3. All right, so I put on one slide here all the 3 formulas that are real important for today's ELR 13.4. So we have probability of 2 independent events. You multiply those. The probability of mutually exclusive events, or if you see that word "or" in the question, is adding those 2 together. And if I have something where they're overlapping, something in common, again with "or" in the question, I'm going to add those 2 events together and subtract what's common between them. So these are the 3 that you need to know and how to use and when to use them. Okay, so for the rest of the period, because it is a block day, you could finish your homework there. Homework 13.4, 6 through 9, and 13 through 21. Make sure I get that via Google Classroom before next class on B block. And then also submit your Google form for attendance for closure for today. Those that would like more work or practice on this ELR today, I've also attached there in Google Classroom 2 different PDFs of compound probabilities. One is mazes and one is task cards. In the PDF, there are answers there. That's what we would have did if we were in school. Hope everyone is doing well. Please, again, email me with any questions that you may have. We have one more lesson on B block, which is going to be on 13.5. We will have a quiz that's going to be on what we did last week and this week. So 13.1 through 13.5, which is what we're learning next class. Okay, I'll talk to everyone soon. And have a great day, everybody.